So good afternoon. This is our second in a series of tech talks that we started last month. And then the plan that we have for computer sciences students on campus is to have these tech talks once a month, once a block on the first Saturday of every block at 1:30. So you can predict that, next block on a Saturday at 1:30, we're going to have another one of these tech talks for you. We have a wide range we have a lot of faculty in our department, and each one of them comes from a different background. We have faculty who are, have a PhD in different areas of computer science. Some of them have worked in the industry for many years. And we thought it would be interesting that each one of them would come and share their experience in their area of expertise with our students. Last one, we had a talk on big data, and so that area, Dr. Khan came and gave a talk. Today, I'm going to be presenting, and what I'm going to be presenting is new features of Java 8. And the history and background on this one is, I've been doing Java for many, many years. About 2 years ago, I attended a conference in San Francisco. Oracle has this major conference called Java 1, which is the biggest conference for Java programmers, and anything Java related happens in San Francisco. Oracle is now the custodian of that conference. And I had a chance to attend it about I think it was almost exactly 2 years ago, before this date, in October of 2014. And that was the year that Oracle introduced Java 8. And I attended a pre-conference training. It was a one-day training. We had about 300 or 400 slides, in that training, the full-day training. And I loved Java 8 and all the new things that Java 8 has added to the language. So I came back. At that time, I was working for a large bank. I came back to my bank, and I thought, okay, I'm gonna actually share this experience and knowledge with my coworkers. So over time, I created some examples, and I created a PowerPoint, and gave a tech talk exactly to my coworkers. In the first session, about 20, 30 people came, and then I started giving a series of tech talks on different features of Java 8. And people liked it, developers and architects across the company liked that, and they came to my talks. And I gave it several times at that time. Then I came to MUM. I was visiting Fairfield, and I gave that tech talk in 2015, spring of 2015. And again, students enjoyed that. So and then just in the past block, I was teaching MPP, and the third week of MPP is Java 8. And I thought it would be nice to have some introduction to Java 8 before we dive in, individual features of Java 8. So I refined my slides, and I gave that talk. And I think this probably serves as an introduction to Java 8. So just as just raise your hand and tell me how many people already know Java 8. Okay? How many people think that they're experts in Java 8? Okay. It's all right. You don't have to be an expert. So for this talk, you only need to know you only need to have some background in Java. Okay. So for today, just some basic knowledge of Java and object-oriented language is enough. And I saw that most of you are already familiar with Java 8, so hopefully it's not going to be too boring for you. Just a little bit of background about me. I did my undergraduate in electrical engineering back in my home country of Iran. And then I came to MUM in 2000 and did my master's in computer science. And since 2000, I've been writing code in Java. And especially between 2010 and 2015, I did a lot of hardcore Java development for some large financial institutions such as Bank of America, Principal Financial Group, Vanguard, and Ally Bank. So that's some background about me. And then in 2015, I decided to join back MUM and teach here. So this is what we're going to talk about. Java 8 is big. It's a revolutionary release of Java. It includes a huge upgrade to the programming language, and as a matter of fact, creators of Java say that this is the biggest change in the programming language since Java was invented about 20 years ago. Java 8 includes features for productivity, ease of use, improved polyglot programming, security, performance, etc. And we look at some of those. This is by no means a comprehensive review of all the features in Java 8, but we're going to review some of the main ones that are probably interesting to us. So this is the 50,000-foot view of what we're going to cover in the next 1 or 2 hours. We are going to talk about lambda expressions and default methods. So lambda expression is probably the biggest feature that was introduced in Java 8 and helps us transform the language into a language that supports functional programming. And then we're going to look at default methods and see what they are. The Stream API is also another huge upgrade to the programming language. I think Java developers have worked years on developing this, and there were ideas. I was looking at an article from 2005 or 2006. There were ideas on creating and adding these features and capabilities to Java, and now Java has it. And the main idea behind the Stream API is everyone uses collections in Java. Almost every single program that you write uses some form of collection. You have a group of objects, and then you need to go through them, you need to filter them, you need to do something to members of that collection. And the Stream API streamlines and helps you do that in a very easy and declarative manner. The new date and time API was introduced in Java. Prior to Java 8, the date and time API was pretty outdated. We had the date class and we had the calendar class, and we had a few supporting classes. But they did a very big overhaul of that API and library, and they created very interesting support for date and time in Java 8. The other big area that was changed was the JavaScript engine. JavaScript engine in Java 7 was called Rhino, and in Java 8 they upgraded it, they added a lot of new features to it, and they called it Nashorn. And Nashorn in German means Rhino, so this is a progression of the same Mozilla Rhino that was introduced in Java 8, the Java 7. Now they have improved it in Java 8. Improved security. There has been a lot of work done in Java 8 for security. Unfortunately, in this lecture, we're not going to have a lot of time to go through that. But just know that the security libraries of Java 8 have expanded quite a bit from what it was in the previous versions of Java. Compact profile is another area that has had a major overhaul. So compact profile, previously Java mainly had 2 or 3 versions. We had the standard edition, or SE. We had the ME version. We had the J2E version. But then if you wanted the whole Java class library, you probably had to have the standard edition. And the standard edition is getting bigger and bigger and bigger over time. So to run that on a small device, so for example, if you have, and then Java runs on a wide variety of devices. We don't just use Java to run banks and big enterprise applications. We sometimes use Java to run a toaster. We sometimes run Java to run a microwave, a TV remote, small devices. And small devices normally have a small memory, and they're limited in terms of the resources. So compact profiles help you run Java just run the core of Java, and then get rid of all the surrounding things that you don't need for running in a large application. So before I start, really, and diving into Java 8, I want to tell you about something that has been my guiding principle over the years of doing computer science. I have to be careful not to touch this cable again. Let me see. Okay. And I learned this principle years ago from Dr. Guthrie in his advanced software development course. And the principle is this. It's also called the fundamental theorem of software engineering. And what it says basically is we can solve any problem in computer science by adding another layer of indirection or abstraction. So if you think about it, any problem that you solve, any design that you do in OO is basically that. You start from a high level, say, okay, from a high level, give me a high-level abstraction of the problem domain. And the high-level abstraction of the problem domain becomes maybe your domain model, or you have a few classes, or you divide the system into multiple subsystems, right? So you create an abstraction of the system. And then you say, okay, how do I design this subsystem? Okay, this subsystem is going to be a group of classes that are collaborating, and what is inside those classes. So you zoom in. You start from the big picture, and then you zoom in, and then you can zoom in as many times as you like. And anytime you get to a complex problem, you say, okay, I don't care about the complexity. Just tell me what it does at a high level. So you encapsulate all the details, and then you deal with it at a high level. So this principle of abstraction is very, very powerful, and I just wanted to draw your attention to it. And you will see that in Java 8, this is used a lot. Okay? So let's dive into a little bit more details and see what these new features of Java 8 are. Lambda expressions, they enable you to treat functionality as a method argument. So think about objects. What are objects, right? In objects, we encapsulate data and then behavior. That's the simplest definition that you can have for an object or a class. And normally, we're all familiar with data objects. You have a person object, has a first name, last name, email address, social security, you name it. But then, how do you represent functionality in Java? Everything is an object in an object-oriented language, with the exception of primitives in Java, but everything else is an object. So how do you represent functionality? Of course, you have to wrap it inside an object. And so that's how you represent a function. So if you have a function, you want to represent it as a class, in Java, you have to wrap it inside a class, and then you have a representation of the object. So this has already been in Java. This idea is not new, but the emphasis of Java 8 is bringing that into highlight and then making that easy to treat functions like method arguments. Wrap them in objects and then pass them around, and then declaration of functions becomes easy, and the whole manipulation of functions becomes much more easier in Java 8. Then we have method references. Method references, this is just a shortcut for calling methods in Java. And I'm going to show you some examples, and through those examples, hopefully you're going to see what I mean. We have default methods in Java, and default methods is a major area. And the idea behind that is up until, and even up until Java 8, Java has always been 100% backwards compatible. Not 100%. In some small cases, they have made some changes, maybe deprecated some libraries, and have actually made changes to them. But for the most part, the Java programming language has remained backwards compatible. Okay, so default, but then the idea comes that, let's say you have an interface and you want to add a method to your interface. What happens to all the classes that are implementing that interface? They all break. You get a compilation error. You have unimplemented methods and you have to implement them. So imagine that you're a Java library developer and you're working on a particular library, you make a change to an interface. There are millions of developers in the world that are using Java, and some of the interfaces in Java are implemented by many, 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 many developers. What happens if you make a change to a public library or popular library, an interface in Java, and then you release a new version of Java, millions of lines of code break, and developers have to go back and fix them. And that would be a disaster. To prevent that disaster, Java introduced the idea of default methods. And default methods tell you that an interface, you can add a new functionality or a new method to your interface, but to avoid breaking code for other developers, you have to provide a default implementation to that new method that you just introduced. So if people like, they can override it. If they don't like it, they can just use the default implementation that you have provided. And that's default methods. Optional class is an interesting idea. Null pointer exception is one of the most common exceptions that almost every Java developer has seen, from the very beginning. It does happen in production. Believe me, I have worked for banks and I have seen null pointer exceptions. All developers make the mistake of, doing something that, causes a null pointer exception. You expect some particular reference to an object to always have a value, and you think that I bet my life and my career that this is never going to be a null, but believe me, don't make assumptions. Anything is possible in this world. And any reference can be null at some point, and then you get a null pointer exception. So the optional class helps you avoid that mistake. Okay, so now let's dive a little bit deeper into functional interfaces and lambdas. What is a functional interface? A functional interface, by definition, is an interface that has a single abstract method. Right? And an example of it is the event handler from the Java FX library. So event handler has exactly one abstract method called handle. Okay? So this fits the description of a SAM or a single abstract method interface or a functional interface. And why do we call this a functional interface? Because if you think about it, you remember I said if you have a function, how do you represent it in Java? You have to put that function inside a class, right? So if you put that function inside a class, then what you create is basically that, a functional interface, and then an implementation for that. So how do we use functional interfaces? Here is a very simple example. Another functional interface is comparator. Comparator has exactly one method called compare. And let's say you have a list of person objects and you want to sort them. What do? Do you write your own sorting algorithms? Well, that's one way to do it. But remember that Java libraries have a rich collection of all sorts of utilities that can be used for different tasks. And then Java collections library is very rich. And then for example, collections is from Java library and has a nice sort method that you can use. You can pass your method, your list or collection, and then it sorts it for you. Now, for sorting objects, what you need is a comparison mechanism. Some objects have an inherent order in them. So, for example, numbers, integer, double, etc. They have they're numbers. They can be compared with each other. But how do you compare two-person objects? And the answer is it depends. It depends on your application. It depends on how you want to do it. Sometimes you may want to compare two persons using age. Sometimes you may want to compare their names. Sometimes you want to compare them by social security. There are different ways of comparison. So, how do you create a comparator? One way to do it is you create a separate class for it. You call it person age comparator, and you provide a particular implementation of the comparison algorithm or comparison rule that you have in mind. And then you see what we are doing here. We have a class, we have wrapped the functionality of comparison in a class. Then we instantiate that class, we create a new person age comparator, an object of that type, and then we pass that object to collections. And then that function has been created, put inside an object, and then we pass it to collections. So far, this is nothing new. This was in Java for a long time. So what is new in Java 8? We could always do this. We could always wrap a function inside a class, and then create an object of it and pass that object, pass it around. So you're passing functionality or behavior around. So this is the progression of, we're going to have a few slides, and then we ultimately are going to get to Lambda expressions. But the next progression is, if you have such a small piece of functionality, oftentimes you don't need to reuse this code. This is code that you write in one place, and then there is no need for reuse. And because there is no need for reuse, you don't need to give this class a name and declare a class for it. So this is a lot of trouble for just achieving something very simple. To simplify that, one way to do it is to have an anonymous inner class. Anonymous inner class is a way of declaring a class on the fly, as you're coding, as you're you're right there, you need an argument. The argument needs to be of a particular type, and that particular type has a very small implementation. You just provide the implementation where you need it and where you need to use it, right? So we can have an anonymous inner class representation of the same. So this is the same thing that the previous application was doing, except that it's a little bit simpler, less lines of code. And believe me, less lines of code is most of the time better, because your program becomes smaller, it's easier to read, it's easier to understand. So how do we do this in Lambdas? How do Lambdas help simplify this situation? Okay? So this is how Lambdas help simplify the situation. We still have the same core of the code that we need to write. Here, you have a lot of extra things. You declare a new class, you have to give it a name, and you have to declare that that class implements comparator, and then you have to, redefine, if you're overriding a method, right? You have to repeat the declaration of the method, and then we provide the implementation of the method. And so you see, we have a few lines of code. Here we have made it a little bit simpler. We don't have the declaration of class. We just name the interface that we are implementing, and then we provide an implementation for the method. But think about it, compiler does not need all of that information. Why? Because the compiler knows that collections.sort expects a comparator object as the second argument. And because compiler knows that, the compiler does not need that extra piece of information. So that comparator can be crossed off. That's redundant. Now, let's go to the next line of code. Public int compare person P1, person P2. That line is also redundant. Why is it redundant? Because that particular interface only has one method in it. And because it has one method in it, we don't need to repeat the name of that method, because compiler already has that information. You don't need to repeat that here. So really the only thing that you need is just one line of code that says P1 get age minus P2 dot get age. So that is the implementation that is unique and you have provided. So that is the added value that you have as a developer. The rest of it is just boilerplate stuff that the compiler already knows about, and you don't even have to provide that. So Lambdas do exactly that. So you only write the minimal amount of information that you need to represent an implementation of a single abstract method interface. Okay? So what do we have in a lambda? A lambda, again, is representing a function. And again, remember what a function is in Java. A function is a single abstract method interface that is implemented by this lambda expression. On the left of the lambda expression, we have the arguments. We have P1, P2 that are our arguments. And on the right side, we have the implementation. You see that there is no return value or return statement, return keyword. Why? Because the compiler already knows it. The compiler already knows that this method is supposed to return something, so whatever you have provided, I'm just going to return it. You can see that there is no type for P1 and P2. We don't say person P1, person P2. Why? Because the compiler already knows that you have a collection of type person, you have a list of person. So of course what you're doing here is P1 and P2. Here you need a comparator of type person. So all of that data is implied. So you don't need to provide that. So again, if you write a lambda expression, like the one above, that would be equivalent to what you have down there as an anonymous inner class. So you're simplifying 1, 2, 3, 4, 5 lines of code into one line of code, and you improve the readability of your program. So that is the main advantage of Lambdas. You improve the readability of your application. You make it more concise and more readable. At the beginning, it may take you some time to get yourself familiarized with the syntax. But once you're familiar with the syntax, it's fairly easy. Any questions so far? Okay. So another example. So remember in the previous example we had a list of person objects. Here we have an array of strings. And this array of strings includes several strings, so some names. and we wish to sort them. Again, Java has a utility called arrays.sort, and you can pass your array, and of course you need the comparator to compare those items. And again, we are beginning to we will begin with having a separate class as a comparator. So your comparison algorithm is return A compared to lowercase b. Okay. How do you do it in using lambdas? You do it like that. Again, remember, you only need to provide the implementation of the compare to method of the comparator. That's all you need to provide here. Every comparator has two arguments. We call them A and B. Those are arbitrary names. You can call them anything. And then on the right side, you just have to provide an implementation for the comparison algorithm that you have in this particular case. Now, I just said that A and B are arbitrary arguments, right? So if they're arbitrary arguments, does the compiler really need them? Not really. The compiler does not need them because the compiler already knows that the compare to ignore requires two arguments. And I can just, if you have two elements and you want to compare them, okay, it's going to, supply the first element as the first argument and supply the second element as the second argument, right? So here we have one of the arguments becomes the object that you call the method on, and the second argument becomes an argument to that method, right? So if the compiler has, and you don't have to call them A, B, you can call them X and Y, you can call them anything. So that piece of information is completely redundant. So the question is, can we get rid of them? And the answer is yes, you can. Okay, so, what are we doing here? We know that the implementation of the comparator is calling the compare to ignore case method of the string class, right? So what it's basically saying is that like I said, the implementation of the compare to method is called the compare to ignore case method. Where are the arguments? How do we deal with the arguments? And the answer is very simple. So this compare to ignore case needs to be called on an object. So the first argument is going to be used as that object. And then this method has an argument, and the second object is going to be used as an argument to this method. That's all. So you see, this is a little bit, at the beginning, may seem a little bit strange, but once you get used to the syntax, it's a very, very concise and precise way of writing a lambda expression. So method references are a very concise way of writing lambda expressions, basically. This is not a lambda expression as per se, but it's providing an implementation for a functional interface. Okay? Any questions so far?
If I go back to the previous slide, I was just curious. So I'm guessing, or you can, I'm not sure if I'm right here, confirm that for me. Does it mean that the internal implementation of the sort method of the arrays class has been modified to handle this new feature?
No.
The sort method still stays the way it was from Java.
Sort method doesn't change. What is changing is, you see, sort method accepts two arguments. The first argument is your collection. The second argument is a comparator object. So this is the implementation of the comparator object. This is the implementation that establishes the comparator object. So from this implementation, Java creates a comparator object and passes it to sort method. Yes?
Before, now in Java, there is a default implementation inside the interface.
Mm-hmm.
So before that, how they did handle like those things, like when they add a new feature, new method interface, they would be...
They did not. The answer is they did not.
So
and in the rare cases that they did, so the question is, okay, so let me actually go to the next slide, and maybe there I explain that because this is related to default methods. Yes?
Here, string is a return type of the method.
I'm sorry?
String. Here, is that return the type of the method?
No.
So what's it?
This is, okay. So basically here what we're saying is we need to provide an implementation. I wish I had a, let me see if there's a laser pointer. Thank you. Okay, so what are we doing here? We are basically providing an implementation, an object of type comparator. And inside that object, we are wrapping the algorithm for comparing two objects. You follow me so far?
Yeah.
So the whole goal of whatever lambda expression, method reference, whatever we're doing here is to provide an object that has wrapped that functionality. So when you're writing a lambda expression, what you're doing is that on the left side you say, okay, these are the arguments, and this is what needs to be done inside that method. So you're providing a body for the single abstract method called compare. So you're providing an implementation for compare, right? So this is what you're doing. This is the implementation of the compare method. Now, what you're doing here is that this is still the same thing. You're providing an implementation for the compare method, but you're saying that the implementation of the compare method is to call the compare to ignore case method of what class? The string class. So you're saying, okay, grab the string class. On the string class, we need to call the compare to ignore case method.
So,
And it could be any other class too, yes.
so in the case of the person, I should provide person. In the case of the, comparing the two persons by age, I should provide person here.
Right, but okay. You can only do that if the person has a method that compares age. But person, it depends. Does the person have a method that compares age? If it's just a POJO, no, it doesn't. But if you add a method to person that compares age, yes, you can say here person, and here say compare age. Yes?
I have a question about when we are saying the Lambda expression or something like that, is an implementation of a class or an interface. Before that, everything in Java was object, and we have a class for that implementation. Like when we look at the bytecode, the compiled code, every
That's
class
right.
and every anonymous class has a physical class.
Mm-hmm.
But I checked the Lambda and I couldn't find any the physical implementation of the bytecode classes for Lambda. So
How exactly does it? Paul, do you know the answer?
I couldn't hear the question.
So the question is, so when you have an inner class, let's say, then what Java does is that inner class is going to be actually compiled into bytecode, and then actually there's going to be a class file associated with it. But how about Lambdas? Are we going to have class files for them?
No. It's done a completely different way. The right way to think about a Lambda is that it imitates the way an anonymous inner class works, but it's implemented in Java very differently. You won't see a .class file. There are differences between anonymous inner class and Lambda expressions that are subtle. Still, it doesn't hurt to think of them as being synonyms for each other, but the actual underlying implementation is very different. Java purposely did not translate Lambda expressions into anonymous inner classes because it would restrict the forward-going evolution of Lambda expressions in a way that they didn't want to do. So that you can read about how Java decided to implement Lambda expressions, but it's really not the same thing. And so one of the advantages is you don't have .class files, so it's more compact.
Right. So the short answer to your question was I don't know, but I think Paul gave you a good explanation and guided you in the right direction. So let's see. The next topic is default methods. Default methods are also known as virtual extension methods. So if you see virtual extension methods in an article, know that it's the same thing as default methods. And what it is basically the answer to, somebody asked, okay, what happens if you add a new method to an interface and it breaks all the classes? And it does, and to prevent that, Java 8 has introduced default methods in interfaces. So now, prior to Java 8, interfaces never had an implementation. And in Java 8 and onwards, they have this implementation, the default implementation for a method. If you introduce a new method to your interface, and you don't want to break, so you can introduce new methods to your interface. There's no problem with that. If it is a very limited application and you have only 3 or 4 implementations of it, and you want to go ahead and change all of those, that's fine. That's the old way. You can still do that. But if you have a big audience, like Java does have a big audience. Like, for example, to comparator, Java has added this method called reverse. And how do they ensure that they don't break? So you saw, I wrote code that had a comparator in it, right? And you know how many millions of lines of code need to be rewritten, just because Java made a change to the comparator interface? And the answer is many, many, many. And to avoid that, Java provides a default implementation for the reverse so that nobody's code is broken. And you can use the same technique for your own interfaces. So this is not just limited to Java class library. And somebody asked what happened, what used to happen in the older versions of Java. And what used to happen was, code would break. In some rare situations that, Java would change a public interface, then if you were to implement that interface, your code would break with a new version of Java. And believe me, that happened to me. I upgraded the application from Java 4 to Java 5, and my application broke just by changing the JD version of my JDK. And I had to go back and change, make some changes to my code. Fortunately, that was not too extensive. Okay, the optional class. Remember that this solves the problem of null pointer exception. And what it is basically a wrapper around your object. Let's say that you have an object of type T, and that object, could be a null reference, and you want to avoid that problem, so you wrap it inside optional, and then optional provides you with a whole bunch of helper methods that help you find out whether the object is null or not. So, for example, we have a method called isPresent. On the wrapper class, you can call isPresent, and then it's going to return true or false, depending whether it's null or not null. And there are many more methods that help you. Get is going to actually get you the actual value of the object that you have wrapped inside the wrapper. So here's an example. So this is going to, hopefully, it's going to clarify that for you. So you have, let's say, this is a computer, and the computer has a sound card, and some computers do not have a sound card. So it's possible that the sound card is null. And let's say that you have, this. If you don't put this if here, then there's a chance that you get a null pointer exception right here. Because what the system.out.println does is that if you pass an object here, it is going to automatically call the toString method of that object. And if this object is null, then if you call the toString method on a null object, obviously you're going to get a null pointer exception. To avoid that, the common practice is, you check to see, okay, is this null or not? If it is not null, only if it is not null, then execute this line of code. Okay, so you have a lot of, this. You may see a lot of this kind of code, in your applications. Having these ifs and then nested ifs and blocks within blocks within blocks of code can get very messy. And following the logic, and a program may not be so simple. There may be multiple lines of code here, and then tracing the logic back, okay, here, okay, you're checking for null. If it is not null, we come down here. But just following that logic is not very simple. To avoid all of that and make your application more readable, what you can do is that you can actually wrap your sound card inside an optional object, optional of type sound card, and then you use it, this is the equivalent of the above. You say sound card, if present, do something. Okay? And here, what are we doing here? You're using method references, right? Because println is a method on class, on basically an object of called out in system. Okay? So system has a static reference inside it called out. and out has a method called println. So actually, this is a little bit different from the last usage that you saw in the previous slide. In the previous slide, we had a class. Here, we have a reference to an object. Out is a reference to an object. And that object has a method called println. So the implementation of what needs to be done to sound card is printed. Now, the question is, what is the type of argument that if present has? And unfortunately, I have already answered that question, but let's actually think about it for a second. So what are we doing inside if present? What we are doing is that we are saying, inside this method, you're going to have probably this if condition, and then what you do here is that you apply a function. Okay? So you're saying, okay, what needs to be done in case the object is present is this, and you're wrapping this functionality in an object, so to speak, and send it inside the if present method. So you wrap, again, the theme of Lambda expression. You wrap functionality inside an object and you pass it around. So that's exactly what you're doing here. So consumer class is one of many Java functional interfaces. And if you want to see the full list of functional interfaces that are provided by Java 8, you can go to Java util function package, and there's a very long list of very generic, general purpose functional interfaces that are provided by Java. I'd like to introduce 4 of them to you that are very, very useful and can be used in many, many applications. One of them is consumer, the other one is predicate, function, and supplier. Let's see what they are, starting with consumer. So consumer is a functional interface, as we said before. And remember the definition of a functional interface. The functional interface has exactly one method. So we have public interface consumer, and consumer has exactly one method called accept. And what accept does is basically accepts an object of type T, does something to T, and doesn't necessarily, well, in this case, does not return anything. Okay? So it's representing any operation that does not have a return value. So it doesn't return anything. It just has some side effects, such as printing the object, sending the object, through networks, saving it to database. Any of those, anything that you want to do to something, to an object, can be accomplished using consumer. And if you want to write Lambda expression that is representing this interface, you do some, this is an example, Lambda expression. So what do we need to do here? We need to provide an implementation of the accept method. So it has one argument exactly. So you have this argument on the left side of Lambda expression. On the right side, you have the body of this method. And the body of this method is just print whatever is passed in. Okay? So then, let's go back here and see what happens here. So you're saying that if the object is not null, then what are you going to do to that? You're wrapping this println or printing functionality as an object and passing it to the method. Next functional interface that I would like to introduce is predicate. What predicate does is it tests. So you pass an object to predicate. Inside predicate, you're running some tests. You're experimenting with the object, poking it. Okay, are you the object that I need? And the answer is either yes or no. So the return, it has a return type, and the return type is a Boolean. An example here is p.getGender equals male. So let's say this is a person object, and you want to see if the person is a male or a female. Okay, so you pass in an object of type P, and what you get back in response is a Boolean, the result of this Boolean expression, which is either true or false. The other one is a function. You can think of it as, how do you represent y equals f of x? You've all seen that, since high school, right? So how do you represent that in Java? This implies that you have an input value of a particular type, and you perform an operation on that input value, and you get to an output value, which could be of a different type. So you have two types, T and R. T is the input, or your X. R is your Y, or output. So you apply some function on top of this value, and you get a result which could in general be of a different value, but could be the same type too. An example of it is this. Your input is P, which is a person object in this case, and your output is you get the email address. An email address could be of type email, could be of type a string, could be a different type. So it's not of type person, it's a different type. And you can use it every time. Excuse me. Oftentimes, when you have a collection of objects, you need to map them, meaning that you have a collection of person objects, but you need to extract their email addresses, or you need to extract a list of their social security numbers. So the input collection is a collection of person, the output collection is a collection of string values. And this is the mapping that can happen, that can help you achieve that. Okay, so supplier is, you can think of it as a generator of objects. It supplies objects, it creates objects for you. But we don't call it creator because it doesn't necessarily create every time you call the supplier. It could be a singleton. It could return the same object over and over again. In this particular example, this is an example implementation of supplier. Every time you're going to get a new object, but it's not always the case. Okay, so let me show you some code. So we talked about, so any questions so far, by the way? No. So we're going to see some quick code, and then we're going to have maybe a 5-minute break, and after that, we continue around a half hour, 45 minutes. Okay, so that's the schedule for today. But before I do that, you're all probably Java programmers here. This is the simplest possible Java program that you can imagine. Just 3 or 4 lines of code, does something, and here's a test. This has nothing to do with Java 8, by the way. I just put it down there, just for fun. And some of the students who were in my class, in my MPP class, have already seen that question, so they can't answer it. So the rest of the people who are here, how many people think it is A? B? C? Do we have anybody for C? D? Okay, how about the rest of the class? They think it's maybe 1,000 or maybe -1. So let's see what this does. You have an initial, you introduce a variable called count, and count is equal to 0. Then you have a loop, right? And the loop, loops exactly 100 times because you go from 0 to 99. So I goes from 0 to 99. 0 to 99 is exactly 100 iterations. So this loop is going to repeat 100 times. Hint. Okay? There's no question about that. And every time you go down here, you do this, whatever it is, you increment count, and then you assign it to count, and then you print count. So you would expect to see the result 100, right? Well, let's run it, see what happens. This is such a simple program, right? This is programming 101. Can anybody tell me why this is 0? Have you seen this before? Okay, you can only answer if you haven't seen this before. Yes. Why is it 0?
Because we are adding 0 plus 0. We didn't add the iterator value like I into the count, so it's going for like.
It doesn't matter. We are incrementing count every time.
But it's already initialized to 0, so we are not giving to any.
No, you see, we are initializing count to 0, and then we are incrementing it. We are incrementing count 100 times. There is no question about that. So why, even though we are incrementing count, why is the value still 0? There is no question about incrementing count. Yes? Byte, is okay. No, that's not the problem. I can change that to int, and it will still be 0. I'm But that's not the problem. Anybody else? Okay, so let me just quickly just tell you. This, by the way, was an interview question.
Change the plus one. Can you change it to plus one?
It's going to solve the problem.
Can you change it to plus one?
So Meysam is suggesting that instead of this, I say plus 1, right?
Yeah.
That is going to solve the issue. But the question is, why is it that this doesn't work? That's the question.
Because it return the void. Count plus plus return the void.
Okay. So maybe think about it and later discuss it among yourself and find out the reason why. But I'm going to tell you very quickly what the reason is. Okay. So may I have everybody's attention for a second? So what happens here is so what this means is that, well, first of all, when we put the plus plus on the right side, it means that we read the value first and then increment it. So we read the value of count, which is 0. We put it in a temporary register, let's call it R, right? So R has a value of 0. Then we increment count, so count now becomes 1, right? So now count is 1. Then we assign the value of the temporary register into count. The value of the temporary register is 0, so we assign it to count. So the value of count was 0. We read it, we incremented it, now it's 1. Then we put 0 back inside count. So that's the reason. What is the solution? Don't do things like that. Do it that way. That's just not right. Okay? So, actually, here's what I'm going to do. I think you've seen enough examples. I'm going to share the examples later with you. Let's take a 5-minute break and then come back in about 5 minutes, and then we'll continue the rest of the lecture.